Here we go. In Prague, some sidewalks are made of small square blocks of stone. The blocks are in different shades to make patterns that are in various sizes. So you see the pattern for pattern number 1, you see number 2, and pattern number 3. Using your pencil, I want you to draw the next pattern that would be in the series. Draw it at the bottom of that page. And once you are done with that, I want you to start filling in the table on page 64, working on that table at the top of the page and problem number 2. Okay? So use your pencil, fill in the next pattern that you see for pattern number 4. And once you're finished with that, start to answer the questions 1 and 2 on the next page. All right, so you have in front of you at the bottom of page 63 a blank area where you could make this graph, okay? So I believe it looks like something like this. And this is very general. And this is 4 by 4. This is a 4 by 4. This is a 4 by 4. And this is a 4 by 4. And again, this is not to scale. Okay, and this is all colored in with the gray or your shaded pencil. All right, how many of you had something like that? Something similar to that? Raise them high. Okay. Sean, you with me? Did you have something like that? Did anyone not have something quite like that? Everybody had that? No, that's not true. I went around, I saw some people didn't have that. So let's take a look at this pattern here. So in the corners here, we have a 1 by 1, right? All the way in the corners. Here we have a 2 by 2. Here we have a 3 by 3. And here we have a 4 by 4, right? So I do see that each of the corners is going to have 16 blocks that are colored in. Now, let's look at these white blocks, okay? Here I have 3 by 1. So that is 3 tiles total. Over here I have 1, 2, 3, 4, 5 by 2. Over here I have 1, 2, 3, 4, 5, 6, 7 by 3. So what does that mean my number of white blocks should be in the center here? What should the pattern follow along with?
12 by 4.
12 by 4? Yeah. Well, wait a minute. We went from 3, 5, 7. How did we jump to 12? Say, is it? 9 by 4. So 9 by 4 means there should be 36 blocks total here. But wait a minute.
I got 12 by 4.
Yeah. So guess what? Those of you that had the 4 by 4s in each of the 4 corners, that is not correct. You should have had a 4 by 4 here that was colored in. Then you should have had 9 blocks by 4 here, then 4 by 4, okay? And then here, this would be 4 by 9, and the 4 by 4 here, okay? So why did so many of you do that? I'll say incorrectly. What threw you off? Let's see, can I do this? Yeah, there we go. So your size of your paper was like this. And what did you do? You made an assumption that all of the corners would have to go in the four corners of the amount of paper that was given, right? So they were tricky. So the pattern didn't necessarily go in all four corners. The pattern, you had to follow both the corners and look at the other. Okay? Oops, that's supposed to be white. So if you can, what you need to make sure is not just to look at a picture quickly and make some assumptions, but, take your time and look at all parts of the picture and see if there is a pattern in different places, not just putting it all in the four corners. Well, they were increasing. Yes, the number of white squares increased by 2, and then by the number of the pattern, right? So then you have this table at the top of your paper. It says pattern number, number of blocks, number of gray blocks, number of white blocks, gray blocks, and number of blocks total. So for figure 1, there are 12 white, there are 13 gray, and the total was 25. For figure 2, there are 40 white blocks. How many gray blocks were there? 41.
Oh, you just add.
Can you count them? Well, you can count them for figure 2, right? Look at figure 2 on the other page. You can actually count those figures, right? So there could have been 41. So added together, there were a total of 81. So for figure 3, and of course I don't have my book up here, number of white blocks. Let me take a look back here. So number 3, the number of white blocks. How many are in this white rectangle up at the top?
21.
21. And how many of those rectangles do we have? 4 of them, right? So that would be 84 white blocks. How many gray blocks do we have?
Oh, they're connected? Wait, they're connected?
What do you mean connected?
This pattern and question 1.
Yes. So gray blocks, 85. Did you count them all? Did you really? Okay. Good, good. So this says 84. So that gives a total of how many? 169. This is for table 3, and then for pattern number 4, pattern 4,
9, 10.
how many white blocks should we have? Which is 36 times 4, 144 for the white. How many gray blocks? Gabe, what do you think? Total number of blocks for number 2 looks to be 40 of the white plus 41 for the gray, which is 81. So white blocks is 144. How many gray blocks? 145 for a total of 289. Any questions about how we got those numbers? You can actually count them, right? You can for those. Now, let's go back to these questions. What do you notice from number 2 about the number of white blocks and the number of gray blocks? Yeah. So the number of white blocks is equal to the number of gray blocks minus 1. So the number of gray blocks is always 1 more, right? So if I have the number of gray blocks, I take that 1 away, then those values would be equal. So the gray blocks are always 1 more than white. There's many ways that you could say it. Okay? Does everybody see that? Okay. Now, number 3 says the total number of blocks can be found by squaring the number of blocks along one side of the pattern. Let me read that again. The total number of blocks can be found by squaring the number of blocks along one side of the pattern. That's true because what shape is this pattern?
Rectangle, square.
Well, is it a rectangle or square? Yeah, it's a square. So the length of the side, when you're finding area, the area is side squared. So when we say, for letter A, fill in the blanks, 25 is equal to 5 squared, that means there are 25 total blocks, right? When we say there are a total of 81, what size square is that? Or what is that equal to? 9 squared. So it's a square of 9 by 9. When I say 169, that's equal to 13 squared. And when I say 289, that's equal to 17 squared. So everybody follow that? Okay. So the next question is letter B. How many blocks will pattern number 5 need?
11 by 5.
21 squared. How did you get that so quickly? Ah, yes. So we went from, this was figure 1, and it was 5 squared. We went to figure 2, and it was 9 squared. So 5 squared plus 4 becomes 9 squared. Figure 3, we had 9, we went to 13. Figure 4, we went from 13, we added 4 and got 17. So if we want figure 5, 17 plus 4 is going to be 21 squared, which is how much? 441. So, how many blocks will pattern number N need? Well, let's see. Figure 2, was that 2 squared? Was it? No, we had a total of 81, which was 9 squared. Figure 3 was 13 squared. Figure 4 was 17 squared. So you have to ask yourself, how am I getting from the figure number to the number of sides that we have? So we went from 1 to 5. We went from 2 to 9. What are some different ways I can get from number 1 to 5? Add 4. So let's see if that works for all of these. So if I have 1 plus 4, that gives me 5. So that works for the first one. Just a minute. So if I do 2 plus 4, that only gives me 6, not 9. So it can't be just to add 4. What are some other things we can do to get from 1 to 5? Right, but we have to use this one. We want to use the figure number because that's all we have when we see these patterns. We know it's figure 1, figure 2, figure 3.
Wouldn't it be like 1 plus if we're doing how many blocks would pattern N be?
1 plus n.
Isn't that what we did the other problem?
Well, if I just do plus 1, 1 plus 1 gives me 2, which is not 5. How else can I get from 1 to 5? Okay, multiply what? By 5. So let's see. Can I take 1 times 5? Yes, I get 5. Can I take 2 times 5? But that gives me 10, and I want to get 9. So I can't just multiply by 5. Okay. So using 1, how can I use subtraction to get from 1 to 5?
6 minus 1.
6 minus 1. Well, I need to use 1. I don't think that's going to work. What if I used a combination of both addition and multiplication? How can I get from 1 to 5? Because we're increasing, right?
So wouldn't that be 1 plus 2 times? No. Wouldn't that be like 1?
Some of you are kind of,
3 plus 2?
well, I got to use 1. I want to use the figure number. So
Yeah.
1 to 5.
1 plus 2.
How can I get from 1 to 5? By either adding and or multiplying. Or how can I get from 2 to 9? Is that a hand or are you thinking? Square roots? No, let's not use that. I don't think that works. Come on, people. I know. This is unlike any other math class, but how else can I get from 1 to 5? What could I multiply by?
5. Wait, no.
Well, we tried that. I could try, well, let's try multiplying by 2. So can I multiply by 2 and then I'd have to add 3? Does that work for this one? 2 times 2 is 4, plus 3 is only 7. So we need to go higher than that. So let's try back over here. 1 times, say it again. Multiply by 4, add 1. Let's see if that works. So 1 times 4 is 4, plus 1 is 5. Okay, so it works for that one. Let's try figure 2. 2 times 4 is 8, plus 1 is 9. Oh, that works, right? So let's try it with 3. So 3 times 4 is 12, plus 1 is 13. And then we have to square it. So pattern N.
That would be N.
N.
N
times 4. Plus 1. Now I want the total number of blocks.
4n plus 1.
Right. That will simplify to 4n plus 1, but that's just one side. So if I want the total blocks squared, yes. So it's n times 4 plus 1, which simplifies to that. And this will be 4n plus 1. That's the length of one side. And then we square it. Okay, does that make sense? You're like, this is crazy. All right. So, does everybody see that? Okay. 4a, if you know the total number of blocks in a pattern, you can work out the number of white blocks in it.
So we were doing the gray box?
No, that was total. This is a different number. So this is total number of blocks. total blocks. All right? But if we know the total in the pattern, we can work out the number of white blocks. Remember?
289 is like the total number.
Well, they're asking a general question here. How can we do this? So if we know the fourth pattern has, say, 289 blocks total, can you figure out how many white blocks there are?
Yeah.
How?
Isn't that like 144 white blocks in total?
Well, there's 289 total.
For the whole thing, and the total of the white ones would be 144.
How did you get that?
Because you just add the number of white blocks. Like,
Yes, but we don't know that yet. You are looking back at it. So if I had 289, how could I quickly figure out the number of white blocks?
Couldn't you do like 620 and divide that by 2 and distribute the 5 between the two?
Why did you say 6? Are you looking at B right now, sort of? Okay, so we'll come back to 4A. But if we have 625 blocks, how could we figure out how many white blocks there were? You said divide by...
What I was thinking was do 620. So take off the 5 and do 620 divided by 2. The gray box is always 1 more. It's 5. Obviously, it's going to split up into 3 and 2.
So if it's... Okay, so if it's always 1 more, why did you take away 5?
Because because obviously if you divide that by 2, you're not gonna get like the exact number. So then what you could do is like, so now maybe 310, and then one of them could be 323, and then the other one 300. Yeah.
Okay, I like the way you're thinking. You are slightly... There's one small piece you're missing.
square root.
No square root. Because we're not multiplying times multiplying. If I have 625 blocks total,
Wouldn't that be?
I'm going to have a number of white blocks and a number of gray blocks, which is the same plus 1, right? So how could I figure out how many white blocks there are? Abel, stay with me. You're like, my brain hurts. You got it? What'd you do?
I just did what I just said.
Well, there's still a little piece that's off. If 625 is the number of white blocks plus gray blocks, and the gray blocks is always 1 more than the number of white,
Subtract 1 first.
yeah, subtract 1 from this first so that they are now both equal. So subtract 1 to get 624 total. Divide that by 2. And how much do we get? 312 white blocks. So if you take away that 1 extra that separates them, then you just take that number and divide by 2. So if we know the total number of blocks in a pattern, how can we work out the number of blocks? The number of blocks in it, white blocks. So you take the total, subtract 1, and divide by 2. And that will give you the number of white blocks. Take your total, subtract 1, and then take that number and divide it by 2 to get your white blocks. Okay? Does that make some sense? Because before they just differed by 1. So if we take that 1 away and then divide by 2, they're going to be the same amount. All right, now that you're really all like, turn to page 66. 66. Page 66. Fred has some colored kitchen floor tiles. He wants to choose a pattern to make a border around the white tiles. He generates patterns by starting with a row of 4 white tiles. Okay, here's my 4 white tiles. 1, 2, 3, 4. He surrounds these 4 tiles with a border of colored tiles. Thus, we have border 1. And the design continues as shown below. So take a look at border 1. I know. That was intentional. Take a look at border 2. What do you see that's the same? From border 1 to border 2 to border 3.
Oh, 4 on the outside.
But from border 1 to 3 on the side, so border 1 starts from 2, and 2 has 3 on the side, and 3 has 4.
Okay. So good. Make sure you're noticing something. Fred writes the expression 4 times quantity border minus 1 and quantity plus 10 for the number of tiles in each border. That's the total, where B is the border number. Why is his expression correct? Why is that correct?
What is correct?
So he came up with this expression, 4 times B minus 1 plus 10. Where is he getting these 10? This 10 that is a constant. It's the same in each pattern. Where are those 10 tiles he's talking about? Okay. The top and bottom, right? Here's 8 of them, and then in border 1, it's the one on the ends, right? So in border number 2, it's still the ones right above, your 4 above, your 4 below, and the 2 on the edges, right? And that's the same for here. So those 10 don't change, okay? That is what the constant is, okay? These 10 are in, I'm going to say in blue. They're X'd out, okay? Where do we get the 4 times B minus 1? Okay, 4 in the middle here times B minus 1. So border is, in this case, 1 minus 1. Number of tiles in the border. Okay, so here we have border 2. 4 times 2 minus 1 is 4 times 1, which is 4. And that accounts for these 4, right? Border 3 has these 4 plus these 4, which is the amount of the plus 10 all in blue, and then 4 times the border minus 1, which basically takes you back to 2. So we can say it works because you take 4 multiplied by 1 less than the border number okay, plus the 10 that remain constant. the 10 that remain constant. Okay? So it's 4 multiplied by 1 less than the border number plus the 10 that remained constant. And that is going to work for you. So everybody got that written down if they want? All right, so we got one more slide. Can I go to that slide or not yet?
Not yet.
Okay. Let me know when you're done. 4 multiplied by basically 1 less than the border number gives you the new ones that are being added each time separate from those constant ones. So now Emma wants to start with 5 tiles. She's going to have 5 tiles in the middle instead of 4. And she says, well, Fred started with 4 tiles and his expression was 4 times b minus 1 and quantity plus 10. So if I start with 5, the expression should be 5 times b minus 1 and quantity plus 10. Is her statement correct? So Fred's was 4 times b minus 1 plus 10. So she says if I'm starting with 5, mine's going to be 5 times b minus 1 plus 10. Is she correct? Got a yes? I got a no? She says yes, but I don't know. Janetta says no. Do you have some reasoning to back it up? Yes? And what is that reasoning?
Since it's 5 boxes, that means the 4 that were above and under the previous one would be also increased by 1.
So how many would be the constant amount?
12?
Yes, excellent. So the constant for her is not going to be 10. It's going to be 12. So the constant amount, so is her statement correct? No, the constant amount added would be 12. So if Emma starts with a row of n tiles, what should her expression be? N tiles. Now look at the patterns we've been dealing with. She starts with n. So it's going to be, what am I going to start with here? N times b minus 1 plus, well, we don't know what n is, so how do we know how to figure that out? You have n tiles. N tiles. Would it not be the number of tiles times 2? So 2n plus these 2 on the ends. So n times b minus 1 plus 2n plus 2, where this is the constant amount. Now, I kind of gave that to you because our time is running out. But does that make sense to you?
Yes.
No? You have 2 times the number of tiles because you have the top side and the bottom side. So that's 2 times the number of tiles you have plus the 2 on the ends. All right, so now you can go on to Unit 1, homework number 2. So see if you can do this by Friday.
I think I still